I'm an associate professor at the School of Computing and Mathematical Sciences of the University of Leicester in the UK. Currently, I'm the director of undergraduate programs in computer science and software engineering. And I obtained my bachelor's degree in computer science in 2002 with an award with the final year project on data migration. This work planted the seeds of a growing interest in modeling data and developing transformation processes to support the evolution of data-driven systems with term rewriting systems. During a short period of time after that, I worked for a research startup participating in the development of a modeling environment for designing and building web applications with UML models. And this environment also used code generators for automating the production of software. So this short participation in industry motivated me to even more to learn even more in the field of MDE and to go back to academia. Once back to academia, I worked on the formalization of the MOD framework for designing modeling languages using algebraic specifications with the term rewriting system MOD. And I obtained my PhD degree in computer science in 2007 from the Technical University of Valencia, or the Universitat Politécnica de Valencia in Spain, while working at the University of Illinois at Urbana-Champaign in the US as a visiting researcher. I joined the University of Leicester in the UK that year in 2007, where I could continue learning about rewriting systems, but this time from a graph transformation perspective. And I have also been a visiting researcher at the Universitat Politécnica de Catalunya to learn more about the graph transformation systems. I have a keen interest in learning about how to engineer trustworthy software systems, particularly data-driven ones. And in model-driven engineering, software models help us learn about complex software systems in ways that code-first software development does not. For example, we can use software models to capture the knowledge of a company that uses a software system. And we can use that knowledge to communicate with expert users so that new extensions of those tools that are already being used can be designed and maintained in order to evolve the existing systems. Software models allow users to represent this domain knowledge in the software code itself in a systematic way, which is quite helpful to trace changes from user requirements to specific code components. On the other hand, we can also use models to study a software system's design and to analyze how the different components of a system interact. Going a little bit further, we can also use models to automate software production by building model compilers, interpreters, and simulators. And ultimately, using explicit software models for specifying software systems, we can also deal with automated verification to build trustworthy systems. I find such versatility of software models quite thrilling, and there is a lot of work to be done until MDE and model-driven engineering technology becomes widely adopted. I also enjoy exploring the benefits of software modeling in education. Modeling languages like UML have been developed over the decades, and they foster sound modeling practices that can be very useful in many different contexts, from analyzing taxonomies of concepts to studying the interactions among different participants in a given scenario. I'm also teaching a module on designing domain-specific modeling languages using MDE principles and technology. And in this context, the current state of affairs of MDE is exciting because now we have the tools to design and develop tool support for our very own modeling languages for a particular domain, which gives us infinite possibilities for automating software engineering processes. My current work in MDE revolves around agile software development for the cloud using Java technology and applications in healthcare and in Industry 4.0. This also in the design and implementation of domain-specific languages using model-driven software development and type theory, and in the application of AI and machine learning technology and formal methods in the intersection of these two areas. My research is usually supported by the engineering of tools for automating software development and verification processes. The last tools I have been working on are Emf Subtyping, which helps on the safe reuse of elements for engineering domain-specific modeling languages, This tool helps in verifying that the structural and behavioral components can be safely reused in a different context. Say, for example, the extension of a metamodel is actually preserving the structure of the components that are being extended, or a model transformation that is applied and extended over a new version of a metamodel. I have also been working on the model transformation language YAML, which is an internal DSL of the Java dialect extent for manipulating software models. This transformation DSL is quite versatile and has proved to be effective at implementing model queries and model-to-model transformations that operate quite fast on very large models that involve millions of objects. This model transformation language offers incrementality features and good compatibility with the JVM tool ecosystem. I have also been involved in the development of technology for enabling the use of MDE technology on data-driven applications in agile software development environments using the Emf Synca. This tool allows us to plug MDE-agnostic Java programs to MDE tools that are based on EMF with an efficient synchronization mechanism for data. From an interdisciplinary perspective, I'm involved in a healthcare project funded by the European Space Agency, where we are applying MDE for engineering a mobile application that will help patients with long-term conditions to improve their health via personalized advice on physical activity. This tool takes into account Earth observation data and medical expertise using machine learning techniques. And this is a large project in collaboration with several departments at the University of Leicester, where I lead the informatics team. I would like to learn how to improve the interface between MDE and tools that are completely agnostic of MDE, but that are still used in engineering modern software systems, mostly involving machine learning techniques. So from that perspective, I would like to explore what is the application of model-driven engineering for data analytics and for implementing artificial intelligence systems. MDENet was born as an inclusive community of researchers and practitioners who want to learn more about MDE while discovering new perspectives and software engineering problems where MDE can provide some leverage to implement solutions. This very idea is what brought me in. MDENet is becoming a strong community of colleagues who want to disseminate results and experiences on MDE while learning about new opportunities. For me, it is a good forum for sharing my knowledge while gaining insight on work developed by colleagues, both in industry and in academia. Given the magnitude of the MDENet community and the caliber of our colleagues in the community, I would say that MDENet allows me to humbly stand on the shoulder of giants to pursue new knowledge and technological advances in model-driven engineering.